We are told the cloud is weightless, a frictionless, silent architecture of information that exists somewhere else. We envision it as an ambient ether, photos floating into the sky, emails dissolving into air, an invisible reservoir where human memory can be stored forever, costless and clean. We've been conditioned to think that going digital means going green, that paperless means weightless. But the cloud is not intangible. It is one of the most resource-intensive industrial architectures ever built. It is a massive heat-generating engine, and it is burning. Beneath the marketing vocabulary of seamless syncing and virtual storage lies a steel and concrete reality. Millions of miles of fiber optic cabling snaking along ocean floors. Monolithic windowless warehouses stretching across rural countryside. Billions of microprocessors screaming at threshold temperatures every second of the day. The cloud isn't in the sky. It's grounded in the dirt, and it is consuming the physical world piece by piece. An audit of our digital infrastructure isn't found in a search bar. It's found in the water. It's found in the heat. To understand the cloud, you have to understand thermodynamics. Every time you stream a video, prompt an AI model, or sync a backup, electricity moves through silicon transistors. Resistance generates heat. Left unchecked, that heat will physically melt the hardware within minutes. To stop digital suicide, we use a primitive solution for a futuristic problem. We pour river water over it. In drought-stricken areas where a vast majority of major new data center clusters are being built, we are not just hosting websites, we are evaporating the future to keep our digital archives from going dark. Consider the geography of data. Companies build in dry, sunny climates because solar energy is cheap and land is vast. But these are the exact regions where aquifers are collapsing. Farmers are forced to let crops rot while nearby cooling towers shoot millions of gallons of pristine groundwater into the atmosphere as steam. We are literally trading drinking water for server cooling. We are draining the river dry to stream high-definition video. The grid is not a moral entity, it is a physical capacity. Power generation is bound by the laws of physics and local infrastructure. When a new town is built, power demand ramps up gradually over decades. When a mega data center cluster arrives, it demands the electrical equivalent of an entire medium-sized city overnight. Data centers are baseload monsters. They don't turn off. They don't flicker. They demand constant, high-voltage electricity 24 hours a day. When the sun sets and the wind drops, intermittent green energy cannot keep them satisfied, so utility companies are forced to react. In places like Virginia and the American Midwest, retired coal plants are being kept on life support, and new fossil gas facilities are being rushed to completion. Not to keep homes lit, but to ensure server uptime never dips below 99.999%. When we cluster these facilities, we are cannibalizing the grid capacity intended for the decarbonization of our physical economy, our transport, our heating, our manufacturing. We are choosing to feed the cloud before we feed the grid that keeps our physical houses warm. We are told that tech companies are buying green energy certificates to offset their footprint. But a paper offset does not change the physical electrons flowing through copper wires at 2 a.m. In real time, the exponential spike in data demand is actively delaying the retirement of fossil fuels. We are paying a physical price for a digital shadow. Every photograph you took 6 years ago and never opened again still resides on a spinning disk or a flash chip in a climate-controlled hall. Every junk mail in your spam folder, every automated analytics pin from a dead website, every redundant database copy, it all requires continuous current. Roughly 70% of the information we store is dark data. Files forgotten, automated system logs no human will ever look at, redundancies built for corporate risk management. We are consuming the power of entire regions to keep digital trash alive in perpetuity. It is a cycle of constant hardware turnover. Scrap and replace, extract and manufacture, all to sustain an economy of ghost files. Server components are stressed to their absolute limits, swapped out every 3 to 5 years, and dumped into global e-waste streams. It's an industrial process of infinite waste for a finite reality. The cloud is burning because we have built it on the assumption of infinite, cheap resources. But we don't have to build it that way. The problem isn't the existence of computing, it's the architecture of indifference. For decades, software and hardware were designed as if power was free and water was limitless. Now physics is forcing a redesign. We are seeing the rise of the tangible cloud, data centers that act as heat exchangers, feeding wasted thermal energy into local district heating. Instead of venting thousands of megawatts of heat into the atmosphere while evaporating rivers, modern facilities are piping water directly into municipal heating grids, warming homes and swimming pools in northern Europe. Edge computing, processing data closer to the user, ending massive, inefficient energy drain of hauling bits across continents. We don't need to turn off the internet. We need to turn off the gluttony. We need a digital infrastructure as finite and respectful as the physical world it inhabits. The cloud can be a utility, not an extraction engine. It depends on whether we value the efficiency of the system or the volume of the noise.